Hi, everyone. In this video, I'm going to cover 5 questions from section P4 in our textbook. In this first problem, we have the sum and difference of 3 polynomials. Each polynomial is in the set of parentheses. So we have polynomial number 1, 5x squared minus 7x plus 8. Polynomial number 2 is 2x squared minus 3x plus 7. And then the third polynomial, we have x squared minus 4x minus 3. So what we want to do is express our answer in standard form. So what standard form means is that we have only one x squared term, we have only one x term, and we have only one number term. So when we look at this, the first thing I want to do is eliminate the parentheses. Let's eliminate the parentheses. So we've got in this first set 5x squared minus 7x plus 8, right? And then we're adding, so this plus sign here affects everything in the next parenthesis. So plus a 2x squared, and then plus a minus 3x, so that'll be minus 3x, and then plus the plus 7, so that's a plus 7. Now in this third polynomial, the x squared minus 4x minus 3, right? Everything in this parenthesis here, everything in this parenthesis is being hit with this negative sign, this minus sign. Right, so make sure you distribute that minus sign to everything in the parentheses. So we're subtracting an x squared. So let's say minus x squared. And then we're subtracting a minus 4x. All right, 2 minuses make a plus. So minus a minus 4x is plus 4x. And then we're minusing a minus 3. Again, 2 minuses make a plus. So that's a plus 3. Now, for our final answer to be in standard form, we have to collect like terms. Collect like terms. So we have this x squared term here, 5x squared. Then we've got a plus 2x squared. And we've got a minus 1x squared. Let me use a little bit of color coding here. I'll switch to green. Then we've got this term here with an x to the first power, a minus 7x. We've got a minus 3x. And we've got a plus 4x. All right. And then we've got our numbers. We've got a plus 8. We've got a plus 7. And we've got a plus 3. All right, so the 3 terms I've circled in blue, those are like terms. So we've got 5x, we've got 5x squared. Then we've got a plus 2x squared. And then over here on the right, we've got a minus x squared. So we've got 5 of these guys, 5x squares. Then we've got 2 more x squares. That gets us 7. Take away 1. That'll give us a total of 6 x squares. Right? And then if we look at the green circles, right, I've got a minus 7x, a minus 3x, and a plus 4x. All right, so minus 7x and a minus 3x. Minus 7x and a minus 3x. And then on the last one, we have a plus 4x. All right, so if we combine these like terms, we've got negative 7, of these x's minus 3x's, that's negative 10x, plus 4, that should give us a negative 6x. And then if we look at the numbers that I've circled in orange, we have plus 8, plus 7, and plus 3. All right, 8 and 7 is 15, plus 3 is 18. So that's a positive 18. And so our final answer in standard form will be 6x squared. I'm looking here, here, and here. All right, we combined all the x squares. We got 6x squared. Minus 6x. We combined all the x's. We got minus 6x. And we have a plus 18. So this is what we call standard form. The exponents, the powers on x are in descending order. We have 6x to the second minus 6x to the first plus 18. And that 18, you could look at that as x to the 0 power or just the constant. And for this polynomial, for this final answer, if it comes up later, you'll maybe need to identify the degree of a polynomial. The degree of a polynomial is the highest power. Right? So what I just highlighted in yellow, the degree of the polynomial is the highest power. So this is a degree 2. Oop, that's not what I wanted. Here's the pen. There we go. There we go. Degree 2 polynomial. So 6x squared minus 6x plus 18. All right, next problem. In the previous problem, we had addition and subtraction. In this case, we have multiplication. So find the product. Remember, the word product means multiplication. All right, so find the product. And we want to express the answer in standard form. So we have polynomial number 1, which is the 3x plus 5. We have polynomial number 2, which is the 2x plus 1. And we want to multiply these two together. You may have seen the mnemonic device FOIL, F-O-I-L. Stands for first, outer, inner, last. So basically, each term in this first set of parentheses has to multiply to each term in the second set. So the 3x has to hit the 2x, and it has to hit the 1. The 5 has to hit the 2x and also has to hit the 1. So FOIL stands for first, outer, inner, last. It's just a way to just systematically go through and do the multiplication. The order doesn't matter. You don't have to do, there's no specific order you have to multiply in, but FOIL stands for first, outer, inner, last. So first term, which is 3x. First term times first term, 3x times 2x. And 3x times 2x will give us 6x squared. Right? 3 times 2 is 6. X times x is x squared. O stands for outer. First, outer, inner, last. So outer is the 3x and the 1. So 3x times 1 is equal to 3x. I stands for inner. That's the 5x and the 5 and the 2x. So 5 times 2x is equal to 10x. 5 times 2 is 10, so 5 times 2x would be 10x. And L stands for last. Last times last would be 5 times 1. And 5 times 1 is equal to 1. So there's your answer. There's your polynomial. Well, not the final answer, but this is what you end up with when you perform the multiplication. And these two guys right here, those are like terms. We got a 3x and a 10x. So that equals 13x. That equals 13x. So our final answer, once we've collected all the like terms, we've got a 6x squared plus 13x plus 1. Another degree 2 polynomial. We'll call these quadratic polynomials. Later, we haven't defined what a quadratic is. At this point, we're just going to call this a degree 2 polynomial. All right, next question, number 3. So number 3, this is just another version of number 2, slightly different numbers, right? So let me go back. Number 2, we had 2 terms times 2 terms. We had 3x plus 5 times 2x plus 1. In this case, we have 2x plus 3 to the second power. Now, what does that mean? What does second power mean? Second power, if you take anything to the second power, it's times itself, right? 2 copies of the same thing multiplied together. So 2x squared plus 3 to the second power is equal to, oh, sorry, not 2x squared, 2x plus 3. So 2x plus 3 to the second power is equal to 2x plus 3 times itself, 2x plus 3. And we could use the same FOIL method, first, outer, inner, last. First times first, 2x times 2x. Well, 2 times 2 is 4. X times x is x squared. So 2x times 2x will be 4x squared. Outer times outer. 2x times 3. 2 times 3 is 6. We've only got 1x, so that's 6x. Inner times inner. So that's 3 times 2x, gives us the same thing. Another 6x, and then last times last, 3 times 3 will give us 9. And just like in the previous problem, we have 2 terms that are like terms. We have a 6x and a 6x, so that equals 12x. So for our final answer, we've got a 4x squared plus 12x plus 9. So we'll say 2x plus 3. All of that raised to the second power is equal to 4x squared plus 12x plus 9. So one common mistake that I've seen in the past multiple times is squaring. So taking that second power and saying, okay, 2x squared is 2x times 2x, and 3x squared is 3 times 3 is 9, and not including what are called the cross terms. That's the 6x and the 6x. So make sure that when you're multiplying 2 polynomials, every term in the first polynomial is multiplied by each term in the second polynomial. Okay, so that does it. That does it for number 3. Let's put we'll do a green box around this guy. That's our final answer. Standard form, powers are in descending order. X to the second, x to the first, and then x to the 0. Okay, so now number 4. This is just a slightly more complicated version of the previous problem. Ooh, that's number 5. Okay. A slightly more complicated version of the previous problem. So now in the first polynomial, this one, we've got 3 terms. In the second polynomial, we've got 3 terms, right? Each of the first 3 has to multiply by each of the second 3. So what that means is this 3x, the one I just circled, that's got to hit the 3x, the 7, and the 5y. Right? Then the 7 has to also hit the 3x, the 7, and the 5y. And then finally, this minus 5y also has to hit the 3x, the 7, and the 5y. Okay, there's too many arrows here. I'm gonna erase these. But every term in this first parenthesis has to multiply by each term in the second parenthesis. So if we start off with the 3x, right? We have to do 3x times 3x, 3x times 7, and 3x times 5y. Okay, so let's do that. 3x times 3x is going to, you know what, I'm going to write a little smaller because we're going to need a little bit more room. 3x times 3x is going to equal 9x squared. 3 times 3 is 9, x times x is x squared. Then we've got the 3x times 7. So 3 times 7 is 21, so that'll give us 21x. And then we've got 3x times 5y. So that will give us, well, 3 times 5 is 15 times an x times a y, 15xy. Okay, so that is just the first term, the first 3x multiplied by everything over here. Now, we move on to the 7. So we're taking a positive 7 times 3x times 7 and times 5y. So there's going to be 9 steps here, nine separate multiplications. So we've got a 7 times 3x. 7 times 3 is 21, so that'll give us 21x. 7 times 7 is 49, and 7 times 5y, 7 times 5y is equal to 35y. 7 times 5 is 35, and then there's a y there. Okay, so that's the 7 multiplied by each term in the second parenthesis. Then we keep going. We move on to the negative 5y is multiplied by the 3x, then it's multiplied by the 7, then it's multiplied by the 5y. All right, so we've got a minus 5y times 3x. And then we've got a minus 5y times 7, and then we've got a minus 5y times positive 5y. So those are the last three terms here. So minus 5y times 3x, minus 5 times 3 is a minus 15. And x, and there's a y and there's an x. Generally, we put our variables in alphabetic order. So I'll say minus 15xy. Technically, you're not wrong if you say minus 15yx, but conventionally, we put our variables in alphabetic order. Next, we got a minus 5y times 7. That'll give us a minus 35y. And we've got a minus 5y times positive 5y. Negative 5 times positive 5 is negative 25. And y times y is y squared. So now we have to collect like terms. All right, we have to collect like terms. So I'm seeing an x squared here, and I'm seeing an x squared here. All right, so we have a 9x squared and a negative 25. Oh, no, that's a y squared. Sorry. Nope, it looks like there's only one x squared. Looks like there's only one x squared. So we've got 9x squared. Then if we look at any of these terms here that just have x to the first power. All right, so we've got a 21x. We've got another 21x. So 21x and 21x, if we combine those, they're both positive. So we add them. That's 42x. That's 42x. So plus 42x. I'm not so concerned with the order. So when I think standard form, the powers are in descending order, but now we have two variables, an x and a y. So the order here doesn't really matter as much. So we've got, so let me do some crossing out. We took care of this guy, 9x squared. We took care of these two 21x's, right? Then we've got an xy. Right, we got 15xy. And then down here, we've got a negative 15xy. So the two terms that both have an xy, oh, they're equal but opposite. One is a positive 15, one is a negative 15. So these two cancel. Positive 15xy, negative 15xy, these guys cancel each other out. Same thing with the 35y and the minus 35y. Right? Equal and opposite. They cancel each other out. So that one's gone. That one's gone. So it looks like the only two terms that are left we haven't accounted for yet. We've got a positive 49. And at the bottom here, we cross out that 49. And at the bottom here, we have a minus 25y. So minus 25y squared, sorry. All right, so there are no more like terms. We have an x squared term, we have an x term, we have a number term, and we have a y squared term. All right, so there's nothing else we could combine, nothing else we could cancel, nothing else we could simplify. So this would be our final answer. All right, so that does it for number 4. Last problem, the last problem, number 5. Write a polynomial in standard form that models the area. Oh, that should say area. It says R. That should say A-R-E-A. The area of the shaded region. So let's think about this one. How do we get that blue shaded region? Well, what we could do is we could take the whole area. And we could take that whole area, and then we could subtract off. We could take away the white area. So the large rectangle minus the small rectangle will give us that blue shaded area that we're looking for. Now, area of a rectangle equals length times width. So that big rectangle, the one that I shaded here in blue, let me go a little bit smaller. That's going to be x plus 3 times x plus 9. And that's going to be the large rectangle. And then we can subtract off this red one. I'll shade it in red. So we could subtract off that one. The area of the rectangle I just shaded in red is going to be x plus 1 times x plus 5, length times width. All right, so x plus 3, x plus 9, that's going to give us the area of the larger rectangle. X plus 1, x plus 5 is going to be the area of the smaller rectangle. And if we subtract the smaller one from the larger one, whatever's left over is going to be that blue shaded region that we're looking for. Okay. So now we have to multiply out, and this is similar to problem 2 and problem 3. So for this first one here, forget about the second one, just look at the first one. Let's multiply that out. X times x is going to be x squared. Outer times outer is going to be x times 9. X times 9, so that's 9x. Positive 9x. Inner times inner is going to be 3 times x, so that's plus 3x. And then last times last, we've got a 3 and a 9. 3 times 9 is 27. And then we're subtracting everything in red. All right, we're subtracting everything in red. And if we multiply that out, first times first, x times x is x squared. Outer times outer, x times 5, so that's 5 plus 5x. Inner times inner, 1 times x, so that would be plus 1x or just x. And last times last, plus 1, or positive 1 has positive 5 is plus 5. So that blue negative, that blue minus sign that I have kind of shaded boldly here is affecting everything in that red parentheses. So we've got x squared plus 9x plus 3x plus 27 minus x squared minus a 5x minus an x and minus a 5. Everything becomes negative in that second parenthesis, from within that second parenthesis. So now let's collect like terms. All right, we've got an x squared here, and we have a minus x squared here. And we have a positive x squared, a negative x squared. So they cancel. Now let's look at the x's. We've got 9 plus 3, right? That's 12x. That's 12 x's right there. Minus a 5x minus a 1x. So if we combine all those numbers, 9 plus 3 is 12, minus 5 is 7, minus 1 brings us down to 6. So we've got a total of 6 x's. And then we've got two numbers. We got a plus 27 and a minus 5. So positive 27 and a minus 5. That's going to give us 22. So once we've done all the multiplication, distributing the minus sign, collecting all the like terms, we end up with the final answer of 6x plus 22. And so that's going to be a equation or an expression that gives us the shaded area, the blue shaded area, based on these two rectangles. All right, that does it for these 5 problems from section P4.